Hey guys, did another video. So a couple days ago I did a video on my transformer that I received, that's right here. And I said I was going to do another video on my big power supply boards. And well, here it is. So I'm going to go over what it looks like, what it can do, and then I'll put a link below for you guys if you just want to contact me and buy a couple boards. But that'll come up. So of course, I don't have a ruler on hand, so I can tell you the measurements. Yes, I do. It's right here. So first, I'll tell you the measurements. The board is 190 mils by 240 mils. Yes, it's big. As you can see, it's fair size. The reason why I made this is because I can't find any good boards online that will handle the current and has all the features that I've put into this board. Now, I worked with Gareth and Tony and Daniel to build this board so it could be multi-purpose for not just only for my F5 build that I'm building, but other amplifiers that I'm building. And I wanted something that was going to work if I was to scale bigger and smaller. And this right here is perfect for that. When you buy these that are old and the layout is just, it's a pain in the ass. So I was like, I'm going to design my own board that's going to be easy to work on, easy to use. I know it's kind of big, but I didn't really care because most of the guys are going to use this are going to use a bigger chassis. Later on in the future, I might make it a little bit smaller or just a different downsize. But the reason for me to building this is because these are the DIY audio boards a lot of guys use for their projects, and I just find that they suck. Their layout is just, it's not well laid out at all. My own, which looks like this, and it works perfect. Why do I know it works perfect? Because I have one running right here, and I have one of my next videos coming up, F5 SMD boards, running both of them off of there, not a single issue. Tested, proven, and working. So my board also uses, I know people aren't going to really like about these because the normal people use those the 35 amp bridge rectifiers that are square, and I think I have one right here. Yes, I do, because it goes into another board. These people are used to using these. I mean, they work great. There's nothing wrong with these. And these are like $7 to $8. This is $15, I think. Maybe 10. Maybe, I can't remember. These will do screw to the chassis. This screws to it like this, and you have no issues. Easy to take apart and change if you ever need to. These bridge rectifiers are similar to the IXYS, but the ones that I chose have AC on one side and DC on the other, whereas the IXYS version of these have AC across corner and then DC, which was really hard to design a board for this, so I went for these ones. But anyways, these just screw to the board, and then you have a spacer that goes between the board, and these, I'll show you in this video right here, because this one's working. Perfect amount of space, and they touch and dissipate the heat really, really well. So not only that, I put fuses on my boards so you could see them. I got LED board on there so that way you can see each rail is lit up. The caps are laid out really, really nice. Like, it's a nice clean layout. And I used screw terminals, and I'll show you in the video right here. I used screw terminals so you can screw your wires on there, and if you have to take the power supply board out, or if you have to take the amplifier off, you can just unscrew the terminals and the wires come off. Something like these, right? So we have the lugs on the end there, and they just screw on there. Works fine, looks great. I actually really like it. And I did CRC, so you can see I put, how many? 1, 2, 3, 4, 5, 6, 7, 8. So you can change your values, right? And I also made it, because some guys want to use these. You can use 50 watt, 25 watt, or 100 watt resistors off the board with this. So if we look right here, here's our CRC, right? And I put terminals here so you can wire the resistors off board with some nice thick wire if you want to, and use these, right? Good idea, yeah? So I'm gonna flip the camera around and go over the board that I've made, and I'll show you it powered up with my transformer that I'm using for my F5. I'll turn on my meter and show you the voltage, and it's working. But yeah, so I just thought I need to design a board that's going to be multi-purpose. If you want a pair of boards, I also have the new F5 boards that I'll review in my upcoming video. But after that, got myself a Jack Russell that likes to bark. Hold on a second. When I come back, I'll flip. Okay, we're back. The Jack Russell's calmed because we had a delivery at the door. Nothing for me, but I'll flip the camera around, and then we'll turn on this, or actually view the board here and go over it, and then show you, and then we'll power up this one. The bridge rectifiers, we have AC, we have a cap that goes across the bridge rectifier, a 0.1 UF. We have the first stage for the low pass, so 2 caps on either side. Then we have our LED for a positive side and negative side, right? And so if we look in the middle here, we have ground, positive and negative, negative, and ground. So this side is positive, this side is negative in our filter. So, and then we have fuses for the positive and negative, and the negatives on this side, okay? So my idea when I was designing this is I'm going to have 3 wires go for one side, 3 wires up here go to the other side, and if we need to, here's our spacing for resistor if you want to get your filter changed. And then we have our next stage of filterization. Okay. We also have a snubber built into it. We have our ground thermistor going to ground. It comes right off of a ridge rectifier. And most people do a star ground for their speakers. So our speaker terminals are right here for negative, ground. And on the back side, flip it over here, we have really, really, really big, huge pores for power, right? Pretty nice setup. Hopefully people like that. Looks pretty good. I'm pretty happy. I spent 2 weeks working on these and printing off many one-to-one PCBs on paper to put these components in and check them and their distances and stuff. So let's move this out of the way and have a look at this guy. This is actually one, hopefully I'm not scratching the plate, the bottom of my amplifier not put together properly, for my F5. So here we go. We have a transformer, the one I just reviewed, from Antec, and then we have the board populated. So we have our resistors elevated off the board, our caps, our fuses, terminals, our thermistor, everything in there. And the nice thing about these terminals is they're not too expensive. I think they're about 20 cents with the screw, and they just solder right in there. Footprints fit perfectly. And then my wires are long right now because I was still testing the board and testing the amplifier. I was using this board, so I haven't shortened these yet. I have to make a little bracket for my board. And I got a little thermistor board for soft start powering up over here. But what we could do, we'll put ground on here, and we'll put positive on here. Turn on our meter. Now I also wanted to note these are green. Usually I go red or blue or some fancy color, but I thought green, it actually looks really good. But also, watch this. Look at that, green lights too. Nice and clear. Just amazing layout that I did. I spent a long time on this, so I bought some extras because I know somebody might be interested. And right now, we got 25 volt rails. There's no load on there right now, so it'll go down maybe a little bit. But that's it right there. And if we look down here, I got spacers. And see how close those are down there? It's touching. So I haven't put screws through here yet. I'm going to put a screw on either side. Right? Screw on either side. And then I'll put a little bit of thermal paste underneath there just to dissipate it. Now, when they get warm, the bottom of the chassis will get will dissipate the heat just fine. And if it doesn't, you could always raise it up a little bit and put aluminum underneath of it to dissipate more. But I did a lot of research. I put these under load and it gets kind of warm, but if it's elevated, the heat will go right through this like a heat sink. And that's my video. Hopefully it was kind of helpful. Hopefully people like it. If you want a board, I'll put a link down below in the description here, and I can ship them off to you. Pretty simple video, nothing really special, but the next video is going to be good because it'll be a pair of F5s in the chassis down there. It's got to get the holes drilled. We should be happening. I'm pretty excited. I'm like 90% close to buttoning this thing up and getting it working. Got a couple things to do. I think I got my soft start filter board. See, I'll print it off another board here, checking clearances and sizes and stuff. But I designed my own soft start board here with a thermistor and some caps. I'm gonna order those. That'll be the last thing that has to go in this chassis. So, hope you liked the video. Thumbs up if you do, thumbs up if you don't. Like and subscribe, all that kind of stuff that people keep saying in all their videos. But yeah, I'll be doing a giveaway pretty soon here, so watch out. You might just get one of these green power supply boards and maybe a pair of F5 boards or something else. So, signing off for the day. Have a good day. Goodbye.